We often assume a sharp boundary separates the living from the inanimate. But does it really? The physicist Erwin Schrödinger offered a distinct perspective. He stated that life is characterized by its ability to resist decay, chaos, and thermal equilibrium. What does this mean, to wrap your head around this? Picture your computer's downloads folder as a miniature universe. It naturally descends into a chaotic mess over time. The only way to restore order and clean up the clutter is by actively spending your own energy. This constant battle against chaos is precisely what defining features of organisms do. Yet, what truly constitutes a living entity? Every organism thriving on Earth is built from fundamental units called cells. Strip away the mystery, and a cell is essentially a protein, constructed machine, far too microscopic to possess consciousness or feelings. Even so, it exhibits all the traits we typically associate with being alive. It features a protective barrier that seals it off from the outside world, creating internal structure. It continuously self-regulates to keep its internal systems stable and consistent. It consumes nutrients to sustain its existence, while growing and maturing along the way. It senses and adapts to environmental changes, evolves over generations, and replicates itself. Crucially, if you isolate any single component of a cell, you will find that none of it is actually alive. Instead, inert matter triggers chemical chain reactions, which spark further reactions in an endless, intricate web. Within a lone cell, millions of these biochemical events occur every single second, executing a flawless molecular symphony. These cells can manufacture thousands of unique proteins, ranging from simple strands to incredibly complex nanomachinery. Imagine speeding down the highway at 100 kilometers an hour, while trying to replace every part of your car using scrap you grab off the asphalt. That impossible feat is exactly how a cell operates day in and day out. And yet, the stark truth remains. Not a single piece of it possesses life. We are looking at completely dead matter, dictated entirely by the fundamental laws of physics. So, is life merely the grand total of these frantic, interconnected chemical processes? In the end, every organism is destined to perish. The core objective of this entire system is simply to delay that demise by generating new vessels. Specifically, DNA. From this view, life is basically an elaborate delivery system designed to ferry genetic codes through time. Driven by natural selection, the specific DNA strands that engineer the most resilient survival machines get to persist. Does that make DNA the actual definition of life? If you isolate a strand of DNA, it reveals itself as nothing more than a highly intricate, inanimate molecule. It cannot perform a single action on its own. This conundrum becomes even stickier when we look at viruses. They are essentially packets of genetic material wrapped in a protein shell, entirely dependent on host cells to function. Science still debates whether they are alive or dead, yet they occupy an astronomical 225 million cubic meters of our planet. Frankly, they seem utterly indifferent to our classification systems. There are even viruses that invade dead cells and reanimate them so they can be a host for them, which blurs the line even more. Or mitochondria. They are the power plants of most complex cells, and were previously free-living bacteria that entered a partnership with bigger cells. They still have their own DNA and can multiply on their own, but they are not alive anymore. They are dead. So they traded their own life for the survival of their DNA, which means living things can evolve into dead things as long as it is beneficial to their genetic code. So maybe life is information that manages to ensure its continued existence. But what about AI, artificial intelligence? By our most common definitions, we are very close to creating artificial life in computers. It is just a question of time before the technology we build gets there. And this is not science fiction either. There are a lot of smart people actively working on this. You could already argue that computer viruses are alive. Okay. So what is life then? Things, processes, DNA, information. This got confusing very fast. One thing is for sure. The idea that life is fundamentally different from non-living things because they contain some non-physical element or are governed by different principles than inanimate objects turns out to be wrong. Before Charles Darwin, humans drew a line between themselves and the rest of living things. There was something magical about us that made us special. Once we had to accept, we are like every living being, a product of evolution. We drew a different line. But the more we learn about what computers can do and how life works, the closer we get to creating the first machine that fits our description of life, the more our image of ourselves is in danger again. And this will happen sooner or later. And here is another question for you. If everything in the universe is made of the same stuff, does this mean everything in the universe is dead? Or that everything in the universe is alive? That it is just a question of complexity? Does this mean we can never die because we were never alive in the first place? Is life and death an irrelevant question, and we haven't noticed it yet? Is it possible we are much more part of the universe around us than we thought? Don't look at us. We don't have any answers for you, just questions for you to think about. After all, it is thinking about questions like this that makes us feel alive and gives us some comfort.